Hello and welcome to another section in further maths. Today we'll be talking about, we'll be looking at ellipse. Now I want us to go into solving some questions that has to do with equations of ellipse. But before then, let us take a brief look at our previous lesson. Okay, welcome back. Now, the last time we stopped at some calculations that has to do with finding the vertices and the foci of an ellipse. Today, I want us to continue into solving some questions under the same topic. Now, let's solve this question. Write the equation. Write the equation of the ellipse 25x squared plus 4y squared minus 50x minus 16y minus 59 equals 0 in the conical form and hence find I, the coordinates of the center of the ellipse, the coordinates of the center of the ellipse. It should be A. Then IIB, the four vertices of the ellipse. And C, the two foci of the ellipse. Now the two foci of the ellipse. Now I want us to continue in solving this question. Now solution. Remember, the equation that was given to us is 25x squared plus 4y squared minus plus 4y squared minus 50x minus 16y minus 59 equals 0. Now with this, I would like us to take the constant term to this other side, because the first question is for us to present the equation in a conical form. So the next thing in our agenda is 25x squared minus 50x plus 4y squared minus 16y equals 59. Then with this, let us make it actually perfect by writing 25 in bracket. So it's x squared. Okay, you take from this point x squared minus 2x plus 1. Okay, minus 25. Then we have plus 4. Bring down the values again. So minus 25 plus 4. Then in bracket y squared minus 16y plus 4 minus 16 equals 59. So let's just move further into performing our cancellation. We have 25 in bracket x squared minus 2x plus 1, then plus 4 y square minus 4y plus 4 equals 100. So now we have 59 plus 16 minus 25. Okay, plus 4 minus 4. Okay, yep. So we now have 25 in bracket x minus 1 squared plus 4 in bracket y minus 2 all squared being equal to 100. Then we divide this point by 4. Remember what we did the last one, and divide here by 25. So it's now x minus 1 all squared over 4 plus y minus 2 all squared over 25, which is equal to 1. So if you compare it with our equation, x minus x prime square over b square plus y minus y prime squared over a square equals to 1, you can see that this equation has actually been placed in its conical form. Now let's look for our value of a and b from what we have here. You bear with me that from inspection we had a to be 25, so our a will be plus or minus. We had our a to be 25 and we have our b to be 4. So we now compare by saying b square is equal to 4. So the value of our b is the square root of 4 plus or minus, which is plus or minus 2, and that of a should be plus or minus square root of 25, which is plus or minus 5. So our answer becomes number 1, the coordinate of the center is now equals. Now our first value, what's our value for x1 and x2, which is 1 and 2. So the vertices of the vertical axis is v in bracket 0 plus x1 a plus y1, which is equals v1 1 and 7, and v is equals 0 plus x1 minus a plus y1, which is equals v2 1 and minus 3. Then vertices on the horizontal. On the horizontal, remember the value of horizontal, which is a, that of a. So we now have v in bracket 0 plus x1 comma 0 plus y1, which is equals v3 in bracket 3 and 2, and we have the second value of our v here, which is in bracket minus b plus x1 then 0 plus y1. Remember we stated it clearly that to assume the value of 0 plus y1, which is now equals, this is a v4, which is minus 1 and 2. Now the last part of it is we're told to also look for the two foci. I think this is very simple because we've been doing this. So for foci we have f, which is 0 plus x1 comma c plus y1, which is equals f1 in bracket 1 comma square root of 21 plus 2, and The second foci will now be same, x plus 0, x1 plus 0, but remember now will now be minus c plus y1. Place the bracket, which is f2, then in bracket you still have 1, but now minus root 21 plus 2. So with this, I would like you to just get ready to take the test that will be coming up in your screen shortly, but always do well to consult the platform for better information on the topic we've just discussed. Thank you, and see you in our next lesson.